Okay, now we want to talk about specific minerals, now that we know how to identify them. We know that minerals are composed of atoms, so what are the atoms that the Earth has that it uses to make these minerals with? And so the first column in this chart shows you that in outer space, the main elements are going to be hydrogen and helium. So the thing that became our solar system consisted of about 99% hydrogen and helium. And then it was about 1% dust and ice. So after the Earth formed, what happened to the hydrogen and the helium? If there was so much hydrogen and helium, why isn't the Earth composed of hydrogen and helium? It's because it's a very light element. Gravity can't grab onto it. So if the Earth had any hydrogen and helium, it just escaped into outer space. What about the ice? Well, we said that when the sun got hot enough, it drove the ice into the middle part of the solar system. So the Earth is basically composed of dust. All right, now what was this dust composed of? So now look at the next column that says what is the Earth composed of as a whole, and you'll notice that there's about 4 major elements that made up this dust. So you've got iron, you got magnesium, you've got oxygen, and then you got silicon. Okay, now let's look at the elements that are in the crust. And do you notice that some of these are greatly reduced and others have been increased? So do you notice that in particular the amount of iron in the crust is very small? Why? Where did the iron go? So when the Earth formed, the heavier elements went to the core. So that's where the iron went. So it's in the core. So there's still iron in the crust, but not as much. Okay, what about the magnesium? Well, the magnesium is a relatively large atom, and so then that means that the minerals that it makes are relatively dense. So magnesium minerals make up the mantle of the Earth, the middle part of the Earth. So what does that leave you for the crust? So in the crust, notice that oxygen and silicon dominate. And so this is going to form the backbone of 90% of all the minerals that are on the surface of the Earth or in the Earth. So silicon and oxygen are going to go together to make that backbone. So the question is why? So here's a picture showing the sizes of those other elements that make up the minerals inside the Earth. But we want to concentrate on the silicon and the oxygen. So let's look at the silicon. Silicon is going to be in column 4 of the periodic table. So that means it's got 4 outer electrons. It's got 4 hooks that it can use to hook onto other atoms with. Well, what it does is it hooks onto oxygens. And so here is, and let's put one more oxygen behind. And so this is going to be called the silica tetrahedron. And this is your basic building block for all of the silicate minerals, the rock-forming minerals. And it all depends on how do these things hook together. So for the exam, I would like for you to know that sometimes they're not hooked together, so that you have isolated silica tetrahedrons. That's what olivine is going to be. Don't worry about the chemical formula for olivine. You would not need to know that for the exam. Sometimes the silica tetrahedrons can be hooked together in a chain. or they can be a double chain. So that's where pyroxene and amphibole, that's where those minerals come from. Sometimes the silica tetrahedrons can be hooked together and make a sheet. That's mica. So I would like for you to know that. Mica is that flat mineral, and the reason why it's flat is because these silica tetrahedrons are hooked together like a piece of paper. And then sometimes they can be hooked together in 3 dimensions, meaning that every one of these oxygens is going to be hooked onto a different silica tetrahedron, and they're all hooked together, and so that's going to be quartz, for example. Okay, you need to know these words for the exam. So you need to know that a silicate has silicon and oxygen in it, and an example of that would be quartz or feldspar. Okay, a carbonate, carbon means it's got carbon in it. So anytime that you see the word 8, that means oxygen. So a silicate is sila, and then the 8 part is the oxygen. Carbonate is going to be carbon and oxygen. An example of that is calcite. So you should know the chemical formula for calcite. So that's going to be calcium carbonate. And then you should know oxides have oxygen in them. An example of this is hematite, which is rust. So it's iron oxide. Okay, a sulfide has sulfur in it. So an example of that would be galena. A sulfate has sulfur. The 8 means oxygen. So it's a sulfate. An example of that is going to be gypsum. Halite is a halide. So halite, halide. A halide is going to be a salt. And so you should know NaCl. So that's an important one to know. And then you can also have native elements such as gold and copper. You can also have hydrides or hydroxides, meaning that they have hydrogen in them, water, and then phosphates have phosphorus in them. So the ones that are in black, you should know the names of those kinds of minerals. All right, so this part here, don't worry about it yet, okay? Because in a future lesson, we're going to talk about igneous rocks, and we're going to talk about the minerals that are in them. Similarly, we will talk about sedimentary rocks and the minerals that are located in them. And we're going to talk about metamorphic rocks and the minerals found in metamorphic rocks. So at this point, you would not need to know that these minerals are found in those kinds of rocks. Then you should know, for example, that aluminum comes from bauxite. So know that for the exam. You should also know that iron comes from hematite, so rust. Let's see. You should know that apatite, that's a very important one, is where we get phosphorus from. Phosphorus comes from apatite, and we use that in fertilizers. You should also know galena. So galena would be a good one to know because that's where we get lead from. Also, bauxite, you should know bauxite. That's where we get aluminum from. Okay, then the important thing to see from this is that the silicate minerals make up over 90% of the minerals found in the rocks, found in the earth. So the silicates are very important minerals. And then don't worry about these charts. Okay, so in lab, you learned how to identify minerals given a identification chart. And so here's the identification charts for minerals, which you will not need to know for the exam. Okay, so that's it. So that's the end of our review. And so I wish you good luck on taking your Unit 1 exam. Bye.